Question 3, practice test 2. Ten students' IQs were tested. The first IQ test was done without exercising before the test. 1 month later, the same 10 students were given an IQ test, different questions, 15 minutes after running 1 mile. The mean difference score is 5, and the estimated variance for the difference score is 9. Using the 0.05 significance level, is it reasonable to conclude that running increases IQ? So in this case, the research hypothesis would be running increases IQ. The research is proposing that if you run before you take an IQ test, it will increase your IQ. So we know this is a directional test. It's going to be a one-tail test. So the opposite of running increases IQ would be the null, which is running decreases IQ or keeps IQ the same. Okay. The next question asks, what is the T critical? Well, we know n equals 10. Now, there are 2 technical groups, but those groups are using the same participants. So we are going to keep the n at 10. So if n equals 10, degrees of freedom equals 9, tails is 1, and the alpha, which is given, is 0.05. Again, find the T critical using degrees of freedom 9, 1 tail, and an alpha of 0.05. You will get 1.833. Next, I wrote down what we were given in the question. We were given the mean difference score, which is 5, and the variance difference score, which is 9. So when you're given this information already and don't have to solve it, the next step you must take to get your T obtained is get the standard error of the mean difference. So in this case, that is the square root of the variance, S squared D, the variance of the difference scores, divided by n. Right? We know the variance is 9 and n is 10, so the square root of 9 divided by 10 equals 0.95. After that, we just simply take the mean difference score, which is 5, divided by the standard error, which is 0.95, to get a T obtained of 5.263. R squared, we use R squared on a repeated measures t-test. So we take the T obtained and square it over the squared T obtained plus the degrees of freedom. You will get these two values, 27.7 over 36.7 equals 0.75. All right, the next is what's the decision on the null hypothesis? The decision on the null hypothesis would be reject the null because we have a T obtained of 5.263, a T critical of 1.833. 5.263 is a lot larger. It's a more extreme score than 1.833. So we reject the null hypothesis. We do have a significant result.